Hi everyone, my name is Thomas Kim. Today is August 1st, 2019. This is my 32nd episode about graph in C++. In this episode, we will learn about C++ containers for heterogeneous types of elements. In our previous episode, episode 28 through episode 31st, I talked about how to extend std-beast, then how to implement types-beast to support a variant of variance. Now in this episode, I will explain how to use C++ containers for heterogeneous types of elements. I extended these container classes for heterogeneous types of elements using C++ standard library. To follow this episode, please visit extension.talkplayfun.com website. If you click this link and unzip it, you can find complete libraries in include folder and also sample source code. Without further ado, let's get started. Start Visual Studio Code. Under CPP extension graph, select graph, click this button. 30-second containers for variance .cpp, hit enter. Ctrl V. I defined advanced types for container classes in this library, especially in TalkPlayFun types HPP. This file becomes pretty huge, and I think this file will further extended in future episodes. So include TalkPlayFun output HPP. We need namespace alias types TalkPlayFun types. I will define stream TalkPlayFun S stream means string stream. Okay, this is a string stream. String stream. Auto NL TalkPlayFun NL. This is simply carriage return. It is defined like this. Auto NL TalkPlayFun NL. This is for flushing to console output. So if you don't flush out to console, you cannot see anything. Void test vector of variance. Okay, if you understand how to use vector of variance, you can use any container classes. So understanding just one type of container classes, you can apply the same rule to any type of C++ container classes. int main. I will copy this function name, copy, and paste it here. So basically we define element type. So name t, I will just use std string, just string type. Using age t, this is simply integer type. Or using weight t, this is double. You can actually define any kind of container classes as element type too, but I will try to make it as simple as possible for easier understanding. Now we create container classes using container t. We define types vector of variance. Okay, vector of variance. This is simply vector of variance. It can hold name t. Okay, elements types are variant. This container, I will give you more explanations shortly, so please be patient with me. Age t, weight t. So it is basically the same like this. std vector std variant it is like a name T, age T, weight T. This is actually the same, okay? This is actually identical, or it can be also thought like this. Variant, because this is string, this is int, okay? And this is double. All these three things are the same. I created this function to simplify this declaration. Or you can even say, for example, if you put weight here, I will put age here, age T. Please note that this age type is repeated. Then the last one, repeated one, is ignored. Okay, it is removed. I hope you understand, because in variant, elements of variant, we cannot repeat the same type. So this type is removed from this class. So with this, I will copy once again for your understanding. So these three, 1, 2, 3, 4 are exactly the same thing. Okay, because the last element type age T is repeated, so this type is removed. Or if you want to make sure the type, you can always display the type like this. Stream, talk, play, fun, get type category. Or you can define another type here using value type from this container class. You can extract value type 2. Okay, in this case, don't forget type name here. Then value type, and there it should be get type name. Okay, with this we can print out start command prompt G++ std C++17 32 containers or containers for variance .cpp, hit enter, cls. So the first type is variant. Variant has the first type is string. This up to this point it is string. Okay, the second type is int. Age is int. Okay, and the last type is double. Weight is double. Even if we include age T here, let's see in this case how it resolves. This one is removed or this one is removed. I don't know. We can test it. CLS. See the last int, this age T. The first type, this is a string type. This is name T. The second type int is age T. Weight is double. Weight is double. For last int is removed because this is vector over variance. In case of variance, you should not specify the same type twice. So it effectively removes repeated type. Now we understand how the types are resolved. Now container type T, we create container. This is vector std, vector std, variant, element is std, string, int, double. Okay, this is exactly the same. This is an instance now. So here we can in place spec, since we are allowed the string type, for example Thomas Kim. Also this is container over vector. Integer types is also allowed. For example 19 Also double type is allowed. Double type 22.0, 7.0, and I will copy once again. I copy and pasted the order doesn't matter. Okay, so we are inserting elements. Now this time I will modify it to 30. Now 21.77. Now this time I will say James Park like this. I inserted some element. Now how can we access each element and we process the variance? These are elements of variance, okay? So we can define like this. Auto handle elements. Okay? Then we can create types, make variant visitors. This is function. This is function, okay? It returns variant visitors. This is function. Or we can just say like this. We are creating an instance that can handle, okay, I will put message here. We are creating an instance of types variant visitors. Okay, we are creating an instance of type variance visitors. Here, this container can hold 3 different types: name, age, weight. I said this repeated types is removed, and we have to keep the order like this. Now here, auto stream. This is global stream. We defined here. We defined this global stream. Auto NL. This is global NL. We cannot access global object in local lambda functions. So here, stream NL auto. The first type is name. This is string type. We don't need to concern about the type because we use auto keyword. All we need to know is the order. The order string in double. So we just say name. Okay. Then stream name is name NL. Okay, we defined one handler. Now I copy this part once again. The second handler is for int type. Okay, age. So I just say age. Then this is age. Age. This is name. This is age. Now I copy once again. Remove this trailing comma. Now the third type is weight. Okay, so we just say weight. Weight. Then it is weight. We created an object here. This is a handler. So we can put it here. We can visit each element for each. We are passing the container. This is the container. We created the container here. So we can pass the container like this. Okay. So this handler for each visits each element of this container and passes to here, to this handler, variant handler. Then we have to flush out and there. I will explain more about this part shortly, so please be patient. Now start command prompt once again. We build CLS, so it displays like this. We defined a vector of variance. That variance can hold string type, integer type, and double type. We placed string, its type is name, and we inserted 19, its age, and this is float type is resolved to weight. Weight is something like this. We inserted more elements, so it is passed properly like this. If you want to beat in reverse order, then you can say for each reverse, okay? Then it beats in reverse order. I will build once again CLS. In this case, the first element is named Thomas, the last element is James Bob. So we are beating in order. In this case, we are beating in reverse order, okay? Or we can beat reverse order like this too. If you want to specify reverse order, types reverse. You can also beat in reverse order like this too. Okay, this is the same. I am trying to explain how to use type reverse. In this case, I build once again CLS. So it is beat in reverse order. This part and this part exactly the same. In more advanced case, we also want to know iterator of the container elements. Once again, we sometimes want to know iterator of the container. So this is vector of variance. We also want to take iterators. Now I copy this part to handle iterator 2. I copied, pasted, then I will change handle elements with iterator. Okay, so in this case we also want to get iterator auto ITR. Okay, now we take iterator 2. Okay, then we can display the type of iterator like this string. Of course we can access type of iterator. Talk, play, fun, get type name. Okay, we can pass iterator type as well. We are displaying iterator type 2. Now I copy this part like this. In this case, we can also get iterators. Now we defined handle elements with the iterator. Now here we can call like this. Handle elements with the iterator. For each iterator, we pass container like this. Okay, so we are visiting each element of the container, but it passes the iterator 2. Okay, to make you concentrate on iterator paths, I will disable it for the time being. When you test your application, please enable them. Now we start with the command prompt. We build once again. Sorry, it should be category name. Category. Okay, I modified like this because this is instance. Okay, now we build once again CLS. So please don't forget flushing out to console string, and we should not forget this part because, as I said, this is a string stream. We have to flush out to console. Now build once again CLS. Now we visit each element and the type of iterator is displayed like this. So we are displaying each iterator type. Now in some case we want to access index of the container. Okay, in such case we can copy this once again. I copied it and pasted it. Now I modify it, handle elements with index. Okay, the syntax is the same. Now this is index. Then I say index, we can display index. I modified like this. I will copy this part once again. Copy, paste, paste. Okay, if we are passing index, now I will change it to index. Index is simply size t type, so we don't need R-value reference format like this. I will simply modify like this because index is size t type. Now with this, I pasted it here for each index. Okay, now I will disable this part. When you try this source code, then you can enable this part. Now here we build once again CLS. From this container we are visiting each element. Index 0 is Thomas Kim. Index Y, the first name is Thomas Kim. Index 0. Okay, it comes later. Then 19 index 1. 3 point blah blah index 2. The last one element is James Bach, index 5. So we can pass index 2. So we are passing index, then we need to access container 2. In this case, we can simply put container. Then we can access the container 2. I copy this, paste, paste. So we can access elements of the container using index 2. But this case, the element is variant, not the value. This is value. So this way we can access container using index 2. Now if you want to visit in reverse order, you can also do like this. Index in reverse. Okay? Then index, reverse index, reverse index. Okay? This is the same. This is in order, this is in reverse order. I will modify it. Index comes first. It's confusing. I will just say index here, index. I will modify like this. It's simpler. Index and index. Here index means the index of the container. Now I modified like this or simplified. Now with this we build once again CLS. Now this is in order. We visit each element. The value is returned through this, but index is also passed. Index 0, index 0, index 1 is age, index 5 is name again. Okay? And in this case, we are visiting in reverse order. This is in order, this is reverse order. So if you want to visit reverse order, you can do this. In the same manner, you can also do like this. Paste it here. Now you can use types reverse. Then it is the same. This part and this part is the same. So I build once again CLS. So it works exactly the same. Please understand that this container is vector of variance. So we can use range based for 2. I will disable it. Ctrl K, Ctrl C. Then we can use for loop 2. For auto BT container. Please note that this container is vector of variance. The element is variant. So here we can use this handler. make vector of variant beast. Okay, each type is types variant visitor. I will copy this instance and paste it here. We can just pass bt or std for the decl type bt2. Okay, this is optional. I will simplify it. I will just do bt. This is the same. With this stream NL. Okay, if we don't do NL, we cannot see anything. Or we can just put here. Now we build once again CLS. Okay, it works perfectly. If we want to paste in reverse order, copy and paste types reverse. Then it pastes in reverse order. I build once again. Now it is pasting in reverse order. This is in order. Now I will enable all. I will enable it. Also enable this part and enable this part and enable this part to test all. Now we build once again CLS, so it works. Up to this point we used vector of variance. We can use any container type. I copied up to this point and paste it here. Now I change the function name, test set of variance. Okay, now I modify this part, set of variance. Now it becomes set like this. Set. Okay, so this is now set. And also here, in case of set, container is set. This is set. Container set do not support in place back. So we simply modify to in place. So with this modification, I copy the function name and paste it here. Now we are testing set of variance. I disable it. In the command prompt, we compile once again CLS. Now this is a set of variance. Okay, it works exactly the same. Please note that in case of set, this is set of variance. Set does not support indexing because it is not random access iterator. Because set of variance does not support random access iterator, but I still implemented accessing through index 2. Okay, I scroll up and copy this part once again, vector of variance. I copied the function before set of variance, copied and paste it here. I will rename it vector of variance variant with vector. Okay, I modified the function name and I will copy this function name and I will paste it here and disable it. I scroll up. I will make it a little bit simplified. I will remove this part. So I simplified like this. In this case, I will introduce another type of a container using bctr t std vector. I will say name t. Okay, so I introduced another vector. This vector bctr will be an element of this vector. Okay, I will copy it here too. Now we introduced another element. Vector itself, vector of a string, becomes an element of this vector of variance. So scrolling down here, we can place anywhere container in place back. We can insert vector of names. Name is a string type, so I create here Sophie Turner. I can put another name, Robert Bach, or another name, the programmer. So I added a vector of strings as element. Please remember the order. This is the last element is vector. So we have to add one more type handler here. Paste. Now this is vector. I say names. This is type of bctrt. This is std vector std string type. Okay, so this is vector. Now we can also access like this for auto and names stream, or we can access like this too, and L. Okay, with this we also can run successfully. In the command prompt, once again I build again. Sorry, I missed one. Compile once again. CLS. Now this is name Sophie Turner, Robert Bach, the programmer. So this part is resolved successfully. Or we can simply do like this too. Ctrl K, Ctrl C, because I overloaded operator names. This is also possible. CLS C names. I will disable this part now. It clutters. So the first element is Thomas Kim, age 19, weight 3.14 blah blah, in place back vector, Sophie Turner, Robert Bach, the programmer, 33, and James Bach. Okay, I will modify it. It's confusing. So everything works fine. So this is container of vector of variance that contains vector as element. In more complicated case, using bctr variant t types vector of variance. Now we can provide age t, weight t. So I inserted, now this is a vector of variance. I will copy this as element. This is the last element. Now this is variant. So we need to provide another handler. I will delete this part. Now I copy and paste. Now this is, I say vector bctr bt. This is bctr vector of variance. this is std variant. In this case, we allowed int and weight. So this is age t, weight t. Okay. Now in this case, we make another one like this. Types make variant visitor. Please note that this is function call, and we pass vctr bt. This is vector over variance, and it contains two elements, stream and L or the first item is int, so age, and the second one is weight. I will remove this trailing comma. I say weight, and I clean up a little bit. Stream, I will copy this text, age, and L. This is weight. Please understand that I am applying the same rule, okay, for each, because this is vector over variance, inner element. So we compile once again. CLS, we have to insert some elements like this here. Now this is BCTR, BT, T. It can be floating point number or integer type. 1, 2, 3, 1.5, 2.3, 4.6. We can put any data. This is vector over variance, integer type and double type. So now if we run it, CLS, it works perfectly. Please note that this vector over variance, this container type does not need to be vector over variance. It can be list over variance too. Okay? We build again. It works successfully. Now this time, this is list over variance. It can be DQ over variance too. Okay? For more container types, right click, go to definition, then currently vector over variance, DQ over variance, list over variance, set over variance, multi-set over variance, unordered set over variance, unordered multi-set over variance, multi-set over variance, map over variance, multi-map over variance, unordered map over variance, unordered multi-map over variance are defined. If you cannot find from here, then you can use it too. Using this, you can create more types. For example, you can define like this too. Container over variance. Now this time you specify std or list or vector, whatever. It doesn't matter. Okay? If your container type over variance is not defined, you can provide container class type like this. Then it builds the same, exactly the same. Okay? Now let's turn our attention to map over variance. Using map over variance is the same to using vector over variance. So I will copy this part, beginning part, and paste it here. I will change the name test map over variance, and I will copy this function name and paste it here. Now here we will define container like this. I need another type name here. Key T. Key T means key type. It can be string or constant character string, whatever. Okay, so simply I use constant character string as key type. Now here, using container t types map over variance t, the first type is key type. Okay, key of the map. Then name t, age t, weight t. So this type is exactly the same like this. Container t is the same to std map key type std variant name t, age t, weight t. So container t is actually defined like this. Okay, now here we declare container t container. We created an instance of container. Please note that this is map. Key type is constant character string. So I say programmer, it can take string or int or double. So I say Thomas Kim, container age. So I was 18 last year, so I am 19. Container weight, say I weigh 61.5 kilograms. Now I copy this part. I have a friend. Her name is Sophie Turner. She is 17 and she is a little bit lighter than me, 55.5 kilograms. So I filled a map over variance. This is key, this is data. So we once again types make variant visitors. Please note that this is function. For each, we visit each element of this container like this, and here we need to define streams. Auto stream we get from global stream, auto NL from global NL we capture stream, capture NL. In case of map, container is map, we need to capture key and value. So here auto key auto, the first type is name. So I say name string. We simply display key is name and L. So I defined one handler for name type. Please note that we have to keep the order. In definition of make variance visitors, we have to keep the order. The first is name. Now I provide a second one. The second one is age. So I say age. And I pasted it here. I copy once again. I remove a trailing comma here. The third type is weight. So the third is weight. Weight. Okay. So it is repeated. Okay. So if it is repeated, it gets the same value. It is overwritten. So I say her age, her weight. Okay. Now with this, I copy this function name, test map over variance. Okay, I pasted it here already. In the command prompt, we build again CLS. Don't forget stream and there we have to flush to console. We build once again CLS. Voila! Programmer is Thomas Kim. Age is 19. Weight is 61. Friend, her age and her weight, everything works properly. Or if you want to display in reverse order, you can either do reverse. In this case, it is displayed in reverse order. So now her weight is displayed first. Programmer Thomas Kim is displayed last. Okay, you can use this one too. Or if you want to recycle it, you can also do like this. Auto, I say just visitor or visitors. In this case, we have to fix like this. Visitor. Okay? We can do the same. The result is the same. CLS, result is the same. Or we can, if we want to recycle it, I will copy this part. Now this is in order. This is in order, this is reverse order. So this is in order, this is reverse order. If you want more complicated data type, for example map, that can contain another vector or another vector of variance, whatever type, I will just simply add another vector using bctrt, or I will try with list t, std, list. I will use std string simply. So I will put, I can put it anywhere. I will put it here. The first type is list now. Okay, please understand that we have to maintain the order. So this is now list. Okay, this is list. This list. I say this is list. Please note that this list is container of type list. So here we can do like this. For auto and list stream key is n nl. Well, I can put more text here. Stream in the list nl stream end of list. Now we will enter some elements here. Container all the bodies. This is list. List can contain strings. James, Amy, Robert, Michelle. So I added the body list. Please understand that we have to preserve the order in this case, in the order of this declaration. Now if we run it, CLS, so in the list, all the bodies James, Amy, Robert, Michelle, end of list. Or we can put another endl here. Sorry, it should not be here. It should be here. So we successfully listed the items. If you want to, you can put end line here too. So everything works fine. In some advanced case, you probably want to use range-based for. For such case, I will disable this part. Ctrl K, Ctrl C for auto BT. Please note that the type of this container is map of variance, so each element is variant. Okay? In this range-based loop, we can use this visitor to copy and paste. We can pass variant like this. Command prompt. We build once again CLS. Sorry, don't forget stream. And there, we have to flush out to console. Build once again CLS. Now it works the same. I will disable this part again. Ctrl K, Ctrl C. Now I will copy this part. Copied it and pasted it here. Now we will make visitors with Iterator. Okay? In this case, we want Iterator of the container element. So we want to get containers Iterator 2 as argument. For such case, we pass auto Iterator. I copy this and paste it here and paste it here. So the first type is Iterator, the second is key, the third is value. Okay? From here, we call like this. For each Iterator, we pass container. If you want to, you can use this Iterator too. Like this. Now in this case, I will disable this part. Ctrl K, Ctrl C, stream. In the list, I will simplify like this. Stream, type of the element, talk, play, fun, get type category, Iterator, and L. So I will copy this part and paste it here. I will put another and there and there. I will copy this part and paste it here. Paste it here. You can access Iterator like this. Now I build once again CLS. Sorry, don't forget stream. And there, we have to flush. Otherwise, we cannot see the result. CLS. Now we can see the list. James, Amy, Robert, Michelle. James, Amy, Robert, Michelle. We can also see the type of element. It is pair. Constant character pointer constant and variant type. Now I will disable this part. Ctrl K, Ctrl C. Ctrl K, Ctrl C, Ctrl K, Ctrl C. Then I will enable all. Now I will enable all these parts. Ctrl K, Ctrl U. I enabled all. Now let's run it. CLS. Now it works perfectly. Last but not least, we can also use an ordered map too, or multi-map. I will copy this part. I copied it and paste it here. I will now rename test unordered map. Okay, so I will copy this function name, copy and paste it here. Scroll up. This is unordered map of variance, so it should be unordered map. Okay, please understand that in case of unordered map, std unordered map does not support reverse iterators. Okay, so reverse part does not work. This is reverse, it does not work in case of unordered map. So I comment out and scroll down. The remainder is the same. So now let's build this part. We are now using unordered map. CLS. Now it works perfectly. This is now unordered map. You can try to use multimap or set over variance, multimap over variance, multimap over unordered variance, etc. In case of multimap or unordered multimap, this indexing operator is not supported. I will not talk about multimap in this episode, but you can try it by yourself. If you want to use Clang compiler, Clang version, Clang compiler version 8.0.0 on M664 MinGW 64-bit build, variant does not work. In such case, you have to visit Clang homepage, click download link, and scroll down. This is LLVM 8.0.0. You have to download pre-built binary. This link. Please download this build and install. Then in Clang compiler, this build will be installed program files LLVM by default. In CPP extension graph supporter, Clang++, std, C++17, FLTO, visibility, public, std. The file name is 32 containers for variance, 32 container for variance, containers for variance, .cpp, hit enter. Sorry, I missed one option here. You have to say X Clang. You have to give this compiler switch. I will make it big with bigger fonts. Now I hope you can see the command prompt. Then hit enter. Now it works. CLS, everything works as expected. Please remember this compiler syntax. I will copy this text, copy and paste it here for your reference. In case of GNU compiler, you can say G++. This is good enough. In case of Microsoft compiler, CL, EHSC, std, C++17, I will copy this file name, then FE, AEXE, the output file name. Let's try with the Microsoft compiler. I paste, hit enter. So Microsoft compiler also builds successfully. In my next episode, I will deal with containers for variance and tuples. by mixing containers of variance and containers for tuples. By working together variance and tuples, we can create any kind of container classes. I will upload complete source code to my website extension talkplayfun.com site. By the time you watch this video, you can click this link and you can download complete source code. If you enjoy it, then in Graphs folder you can find the complete source code of this episode. Please subscribe to my YouTube channel. Thank you for watching.